which resonance form best explains the greater acidity of para-nitrophenol relative to phenol? So A, B, C, and D are all forms of paraphenol, either the acidic form, in this case, or the conjugate base form, right? So, how do we determine acidity? Greater, lesser acidity, right? We want to look at the stability of the conjugate base, right? For acidity, acid will donate a proton and leave it in the conjugate base form, right? The more stable this guy is, the further on this side equilibrium lies, which means the more likely this guy is to donate an H plus and become A minus. So the stronger acid is. So we want to look at the conjugate base of paraphenol, phenol, compare them, see in which way paraphenol is more stable in its conjugate base form than phenol. So basically, which resonance structure will show that paraphenol as a conjugate base is more stable. Right, so let's try to do that. So here's paraphenol, right? So here we go. Phenol, N, let's go O, O minus, plus. Okay, so, right, this guy will lose his proton, come minus charge up here. The more we can delocalize this minus charge on the O, the more stable this will be, right? So of course we can delocalize this here, and let's right away compare it to phenol. Let's do that, let's do it side by side. So here would be phenol, its conjugate base, right? So of course phenol could also do this here, right? It could go like this, right? So we could for both of these guys, we could go like this, okay? Right, so here's one resonance form for both of these guys. O, O minus, plus, so we went, let me see, like double bond O, this, right? So same thing here. So right, a resonance form like this does not show any difference between these two guys, correct? Let's see if any of these, okay, so that's this resonance form, right? So this is not going to be the answer because it does not explain the difference between these two guys, right? Because they both have this resonance form showing some displacement of charge from the O. So B does not explain a difference between the conjugate base stability of para-nitrophenol and phenol. Okay? And so of course we could move this minus charge all around this guy, right? We could go here, and let me see, double bond here, put a positive charge here. So wait, we'd want to go, I draw this thing? Okay, right here. Right, so you could put, definitely, well, where would the, screwing up with the charge somehow, so we had a minus charge here. So if we go there, neutral, wouldn't we get a minus charge over here? Okay. So why am I having trouble with this? Oh, well I got these two guys right next to each other. So this should have been on this side originally. Right, it was up here. This guy too. Okay. See, I moved these guys around here. So sorry about that mistake. Right? Okay, so this should have been here. So if we move this here, we could very well move this guy here, right, and get a minus charge here and a double bond here. Then we can move this again and get a double bond here and a minus charge here. So we can delocalize for both of these guys, right? Minus charge all around the aromatic ring, okay, just like B, right? So the difference between paraphenol, para-nitrophenol, and phenol is the ability to delocalize this minus charge beyond the ring into this substituent here, right? This nitro, a nitro group on an aromatic ring is, right, it is a deactivating substituent for electrophilic addition reactions to a benzene ring. So What that means is it draws electron density away from the benzene ring, making it less of a nucleophile in spots, allowing electrophiles to attack. But in terms of pKa, it takes electron density away from the negative charge or neutral charge, but negative charge of the conjugate base. It stabilizes the conjugate base, right? So we can show that with resonance, right? If we bring this down here, right, we can go to here through resonance, and then we could go, let's see, to here through resonance, and then to here, and let's see what we get, right? So we went double bond, double bond, double bond, double bond here, O minus, O minus. So this is another resonance form of the conjugate base. The more resonance forms a molecule has, the more it's going to be stabilized, especially stable resonance forms. This guy's pretty stable, right? It's got a minus charge on the more electronegative oxygen atoms with a positive charge on the nitrogen atoms. Right, this is pretty stable. This clearly shows the conjugate base stabilized in a way that cannot be shown with the phenol's conjugate base, right? And if we look over here, right, that is option D. So let's see what's wrong with A and B. Let's see. So O, just lost one. So O shows nothing. O shows just this is the form before the resonance, before any resonance. So this is the form before I started pushing arrows around here, right? So phenol will also have a form, right, that's just like this. So it shows no difference between the phenolate ion, the conjugate base of phenol. So this guy, well, it violates, well, it changed compounds. It lost an H, so this is a different compound completely. Or did it lose an H? No, we just have 1, 2, 3, 4, 5 bonds, so we break the octet rule here, so that's no good. We just saw why A had nothing to do with comparing paraphenol to phenol, paranitrophenol to phenol. So D, shouldn't it be a minus here? Did I screw it up? Hold up. Okay, my bad. Hold up on this video. This is no good because it's not the conjugate base. But my whole explanation was right. What I did wrong was I drew this wrong, this guy wrong here, so it should be, okay, C. This should have been option C, which is what we had here, right? So this, I wasn't paying attention to that H up there. Looking through this, C. Okay, right. I totally drew C wrong. I do not know what happened. So that is my mistake big time. So now this video is probably going way on. But let me just check. So C is good. This is not a conjugate base. Right. So this, they pulled this guy back. Move this guy. So I guess you could do that. So this is a resonance resonance form of the paranitrophenol, but not of the conjugate base. So we're not interested in it. We want to see the stability of the conjugate base in order to determine acidity. So sorry for the mistake. C is the right answer.